Hello, I'm Ron Brook, a fisheries scientist with the University of Wisconsin-Milwaukee School of Freshwater Sciences. And I'm here today at the school with my colleague Fred Minkowski to tell you the story of our fisheries research on Long Lake up in Vilas County, Wisconsin, and the implications of that work. The title of the talk, Cisco, Smelt, Lake Trout, and Walleye Management in Long Lake of Phelps, Vilas County, Wisconsin. And again, this is work through the University of Wisconsin-Milwaukee School of Freshwater Sciences, research conducted through that school. And it's also funded by the Long Lake of Phelps Lake District. Long Lake is a beautiful oligotrophic lake, a deep water lake in northern Wisconsin, not far from the Michigan border, 886 acres with a maximum depth of 95 feet. It has a very beautiful shoreline. When you're on the lake, you almost think you're up in Canada because most of the homes and cottages that are built on the lake are built way off the water, and the shoreline is pretty well not disturbed. So it's an absolutely beautiful lake, very good water quality, deep lake. And it has a lake district, which is a taxing body. And this presentation is specifically, I'm making this specifically for the members of that lake district who pay the taxes on this lake, that contributed the funds to the lake district that paid for this research. So in the lake itself, there's some very nice fisheries in the lake, and it has a long history of having good fishing on the lake, especially for walleye up on the left here, and muskie on the right, large muskie. But another very important component of the fish community is this fish in the middle, which is a Cisco. It's a cold water fish. It's in the salmonid family. And this is a fish that lives in the deep cold waters of the lake. It's a native fish, and it's a very important forage fish because these Cisco in the lake, they typically don't get much larger than 15 to 16 inches, and they're very good prey for muskies and walleyes in the lake that will go down into the cold water in the deeper areas to feed. Historically, there have been other cold water fish that have also been stocked in the lake, rainbow trout, brown trout, and brook trout. And from 1971 to 1995, over 361,000 of these salmonid species were stocked into Long Lake because it did have the cold water year-round below what we'll call the thermocline, where the water stratifies in the summer and you have warm water above and cold water below, and they could live in that part of the lake. And they were stocked up until 1995, which stocking ended 4 years before smelt were first found in the lake. This species is an exotic species. It's rainbow smelt. Many people know about smelt from experiences they may have had on the Great Lakes, on Lake Michigan or Lake Superior, where they've gone smelting in the spring of the year. They're an exotic species in the Great Lakes as well. They come from the Atlantic Ocean and from the coast of the Northeast, New England coast, and some inland lakes in Maine. And they've been in the Great Lakes since the early part of the 20th century. And in 1999, they were first found in Long Lake. And presently, they're in about almost 40 different lakes in northern Wisconsin where they've been illegally introduced primarily to by whoever. And they have apparently have caused some problems in the lakes that they're in. So in 2005, the DNR started stocking extended growth walleye fingerlings. And these are walleye fingerlings that would be on the average about 7 inches long, which is 2 to 3 times larger than the typical walleye that the DNR stocked in the lake historically. And these larger walleyes have very good survival. They survive at a much higher rate than the typical small walleyes that the DNR used to stock. And the chances are they're going to survive, and then it was hoped that they would eat smelt to help control the smelt. And so they do that every other year in odd years, the DNR does. They stock 10 per acre or about 10,000 walleyes in the lake every other year. And the Lake District itself actually stocked 3 per acre in 2008, 2012, 10 and 2012. They put walleyes in the lake as well to get more fish in there to eat smelt. Then in 2005, the DNR also started stocking lake trout. And these are lake trout that were they were raised by the DNR hatcheries from eggs that were taken from native lake trout in a lake that's only 17 miles northwest of the Long Lake called Black Oak Lake that has a unique genetic strain of native lake trout that lives in that lake. And they've been stocked in 2005, 12, 13, 17, and 18. So the DNR put these large predators in, put lake trout in, for smelt control and specifically with lake trout for gene pool preservation, because that's a unique genetic strain. That's the only place that that genetic strain of lake trout is found or has been found to date is in that Black Oak Lake, and they're trying to get 3 other populations established in Long Lake, Lake Lucerne, and Big Car Lake. And in Long Lake, they're in there also to eat smelt. So by 2016, the Long Lake of Phelps Lake District had a number of questions or concerns about different elements of the fishery. One, what is the fate of the Cisco population? What is the status of the smelt in the lake? What's the survival of the stocked lake trout? Because nobody had really sampled. If you hear, they heard anecdotal stories about people catching lake trout. Are they surviving? Are they eating smelt? And are they attempting to spawn in the lake? Because the long-term goal of the DNR is to get a naturally reproducing population of lake trout in the lake so that they could continue through time to control smelt in the lake. And then are the walleye eating smelt, and are they reproducing? And the story about reproduction on the walleye and smelt is, or the walleye and the lake trout is important because the paradigm for walleye, especially in northern Wisconsin lakes that have been invaded by smelt, is that somehow the smelt disrupts walleye reproduction. The DNR data indicates that that might be the case. And so it would be important to know whether walleye are reproducing in Long Lake, a lake that's full of smelt. With the lake trout, it's been shown that lake trout that eat lots of smelt, that have more than 50% of their diet with smelt, have trouble reproducing because of an enzyme that the smelt have in them. And we'll get into that a little bit later. So the Lake District set up a series of research agreements with the school to attempt to answer questions and provide additional information for long-term management of the fisheries in the lake. By the way, this picture, this is Long Lake, this is Big Sand Lake in the background, and I found this picture on the Long Lake of Phelps Lake District website. It's a photo by Josh Wilson. Anyway, so the fate of the Cisco population. Again, a picture of a Cisco. In 2016, when we first started this project, we met with the DNR, and one of the biggest concerns the DNR had at the time was were the smelt impacting the Cisco? Because in other lakes that smelt had invaded, they found that the Cisco populations also didn't seem to be reproducing or as abundant as they were before. They didn't know the interaction. They thought maybe the smelt might be eating the small Cisco. Smelt are very voracious predators. And they thought they might be eating the small Cisco or competing with them for food or doing something to cause problems for the Cisco population. And they thought at the time in 2016 that the Cisco were at a very dangerously low level in Long Lake, the native Cisco. So the very first project that we did, the very first work that we did was collect eggs to rear fish here at the lab, at the school here in Milwaukee, to raise Cisco to stock in the lake. Basically get some Cisco into the lake if the Cisco are down. So on November 22nd, 2016, Fred and I and several other people went to North Twin Lake, which is only about 3 miles away from Long Lake, which also has a native Cisco population. And on a very cold night, the air temperature was about 15 degrees, we collected eggs and collected sperm, fertilized them. Fred brought them back here to the lab, and through some absolutely tender loving care was able to raise fish in his lab where eventually 10,000 extended growth fingerlings were stocked out in the fall of 2018. So a year later, the fish that Fred raised were stocked out. All these fingerlings were fin clipped. These fingerling Ciscos were fin clipped so they could be identified as the stocked fish if anybody ran into them in surveys or otherwise later on. Also, these fish were 5 times the weight of wild Cisco fingerlings and twice as long as wild Cisco fingerlings. So, and a fingerling being a fish hatched in that year through the first summer's growth, so in the fall of the year. These were very beautiful fish that Fred raised, and nobody can do it better than Fred. But anyways, after that, we started doing test netting in the lake for lake trout, and we caught Cisco. We didn't catch many lake trout, but we caught Cisco everywhere we set those nets in the lake. So the native Cisco population still persisted at a higher level than we first were led to believe or first thought. And so we had the stock Cisco in there, plus we had what seemed to be a fairly decent native Cisco population left in the lake. We were curious as to how old these Cisco were and whether these Cisco were actually reproducing in the presence of smelt. And we found out, we took otoliths, which is the ear stone, comes out of the head of the fish, cross-section that otolith, and lo and behold, we found Ciscos that were 9 to 22 years of age, and they had, which indicating they were having regular hatches throughout the entire time period that smelt were in the lake. So it didn't appear that the smelt were negatively impacting the Cisco reproductive ability. The other interesting thing we found out is when we did stomach analysis on the Cisco, in the late summer they were eating fingerling perch and bluegill. And you might say, well, what's the big deal? Fish eat fish. Cisco are not typically known as fish-eating fish. They typically like to eat aquatic insects and zooplankton that are in the lake, and they're insectivores and planktivores. For them to eat fish is very uncommon. And we found lots of fingerling perch. These are all fingerling perch. And the next summer in 2020, we found lots of, or 2019, we found lots of fingerling bluegills. There was a very strong hatch of perch in 2018, and apparently a strong hatch of bluegills in 2019. And the Ciscos were taking advantage of them. And you might ask why? Well, it's a possibility that the smelt may have cropped off the zooplankton that the Cisco like to eat, because the Cisco are living in the same place that the smelt are in the cold water, and they had to turn to other food. And they found these bluegills and fingerling perch apparently perhaps in a zone of water that was still cold enough for the Cisco to be comfortable and take advantage of this forage item. So Cisco are a very important native deep water forage fish for the lake. If you didn't have the smelt in there, it would be the only thing that would be to eat in that cold water. So walleyes and other fish, but especially walleyes, big fish predators like that are native to this lake, that can live in the warm water along shore, plus go down and be comfortable in the cold water, they would take advantage of these Cisco and eat these Cisco on a regular basis, along with other fish like muskie. So they're very important to the overall dynamics of the lake. So the status of smelt. Again, going into this, nobody had ever sampled the smelt in Long Lake, other than when they first came in and they became very abundant. There was one or a few occasions where people would net them in the spring of the year when they would come into the creeks or go out of the Deerskin River and spawn, and people would net them, but that hadn't been done on a regular basis for a long time. And so there was literally no information on what the smelt even looked like in the lake. So they were known to be abundant, but there was no knowledge of the status of the population in the lake, what their impact might be on the lake, or if the predators were eating or impacting them. And that was the whole idea of stocking the lake trout and stocking the walleyes, was put enough predators in there that they could possibly negatively impact the smelt and drive their population down. So it didn't take us long to find out that they were abundant. You go out on the lake, you have a fish finder. This is a Lowrance TI-7 screen. Wherever you go on the lake, you'll find these smelt balls, we call them. It's large schools of smelt that show up on your sounder. There were times when we'd be traveling along in the lake, 50, 60, 70, 80, 90 feet of water, where there would be such a large smelt ball under the boat, the sounder could not pound through it to see what the real bottom was, that we actually thought we found new reefs in Long Lake. We'd mark a waypoint on that, come back later on, find this reef, we could set a net on it. It was gone. It was completely gone. So the smelt are very abundant in the lake, but they're small. We sample these fish with a trawl. I got a picture I'll show you later on, but it's basically a big funnel net that you drag behind the boat through the water column, and it just catches whatever in front of it. And that's how we found the best way to sample smelt. And most of the smelt, this line here is 4 inches. Probably 95% of the smelt in the lake that we captured and all the time we sampled out there were less than 4 inches, which is much different than what people can remember from their experience on the Great Lakes. Because people that go out smelting on the Great Lakes, including myself, can remember probably 7, 8 inch smelt, at least the ones that you didn't bite the head off of yet, because on Lake Michigan, the first smelt you get, you're supposed to bite the head off and then drink a beer. But the smaller you never saw smaller fish like this in the seines where you smelted on Lake Michigan, down on Bradford Beach or wherever. And so it was quite surprising when that's all we caught were these smaller smelt. So we started looking at them, we started measuring them, weighing them, looking at the sex, are they mature, are they immature? Smelt this size in Lake Michigan or other waters on the East Coast that have smelt would not be mature fish. We found mature fish down to 3 inches. This is a female with eggs right here that's only 3 inches long. And that's, when I looked it up in the literature, it's a condition called dwarfing, where the smelt actually, because of pressures on the population, which in this case we suspect because of pressure from predation, and this happens with other species as well, they start spawning at a smaller size and a younger age to compensate for the loss of the larger, older individuals in a population that used to be the prime spawners. So we found that happening with the smelt in Long Lake. We also took otoliths from the smelt, like we did the Cisco, the ear stones, the little ear stones in the heads of the fish, and these are really tiny little things. And we found the smelt to be up to 6 years old, up to almost 7 years old. So, and hatching, you're getting a hatch almost every year. Out of the 7 years of the span of the ages of smelt that we found, there was a hatch every year except 1 year that we sampled. And the other important thing we found is that they have what we call in the science and fisheries business a total annual mortality rate of 67%. In other words, 67% of all the smelt in Long Lake are dying each year, dying from natural causes or from being eaten, because there's no fishery on this lake for smelt, so they're not dying from any fishing mortality. It's all natural mortality, which is, in this case, more than likely primarily by being eaten by other fish, including probably other smelt. And we did find that walleye and trout are eating lots of them, and these are 2 emaciated smelt taken from a 25-inch walleye that we caught angling and kept to do some evaluation of. And we found smelt in the lake trout stomachs were packed with smelt, and the walleye stomachs were packed with smelt, and everything we looked at. So the walleye and lake trout were eating lots of smelt. So smelt in Long Lake is actually an important forage fish because the main predators are feeding heavily on it. They're growing really well. But the questions of impact of smelt and Cisco on walleye reproduction, we already showed that the Cisco appear to be reproducing with the smelt in the lake. And what about the walleye? And we'll get into that in a little while. And then what about the impact on lake trout reproduction? The enzyme I mentioned before, it's called thymidase. And smelt being, they're from the ocean, and they're another invader in the Great Lakes that people can relate to that have thymidase is alewife. Back in the 60s, they littered the shoreline, dead alewife, so DNR started stocking salmon, and trout and salmon in Lake Michigan, they eat the alewife and eat the smelt. Well, now alewife is almost an endangered species out there. They manage the lake to keep enough alewife around to support the salmon fishery. They've done a good job. So, and the smelt have all but disappeared from the predation in the lake. But what they found out for many, many years is the lake trout could not reproduce in Lake Michigan. And they thought it wasn't the right kind of reef or the right kind of strain of lake trout or whatever. They found out that because they were eating alewife and smelt, more than 50% of their diet, this enzyme thymidase was breaking down the vitamin B12 in the fish, which they need for reproduction. And so the fish could not reproduce. They had what's called early mortality syndrome. The larvae or the eggs would die because they had a vitamin B12 deficiency. So that's the thymidase issues, and they've shown it on lake trout. It hasn't been shown for other species such as walleye. And then finally, what's the impact on the aquatic community? I already mentioned that the smelt may have been eating so many zooplankton that the Cisco liked to eat that the Cisco had to turn to fish. And the work that's been done on the lake has shown that the zooplankton that are in the lake are much smaller zooplankton than what you would normally find in Long Lake. And it's probably because of the massive amounts of smelt that are in there that are eating zooplankton in a large amount. So on to the lake trout. Are the lake trout surviving, eating smelt, and attempting to spawn? So from August 2017 to October 2019, we captured 12 adult lake trout through angling, trolling, and 4 in our gill nets, 2.5-inch stretch mesh monofilament gill nets. We surgically implanted 10-year sonic tags. So these are tags that last 10 years. They send signals for 10 years in 6 fish. 2.5-year radio tags in 4 fish, excuse me, in both tags in 3. And then 1 fish was too small, so we just put a pit tag in it, which was like a little, it's like a little passive transponder that people put in their pets. It's the same thing. So we had 13 fish that we had tagged out there total. Everything we did a lot of this in the summertime, and the surface water is very warm, so you got to be very careful with lake trout because they prefer to have a body temperature of about 45 to 50 degrees. The surface water could be 75 degrees. The top 20 feet is going to be warm until you get to the thermocline where it drops off very rapidly to 50 to 40 degrees. But when you bring them up in that warm water and the surface water by fishing for them, it can cause problems. So all of our tanks, we had either iced or we had chillers in to make sure that all the coolers, everything was the proper temperature, and they handled things quite well. This lake trout right here, you can see there's a tag hanging out of its belly. That's the antenna from the radio tag that was put in the fish. Here's the incision where that radio tag went in. This fish also has a sonic tag in it as well, so it has both tags. It was large enough for both tags. And then on the back here, it's got this little red spaghetti tag that says DNR Woodruff on it, and that's an exterior tag, so if people catch a fish with that tag, they know that that fish has some kind of telemetry tag inside. And then we would go out and track in all kinds of weather, all kinds of conditions. And lake trout spawn in the fall of the year, so you have to be out in the fall of the year to track them because one of the objects was to try to find out where they're spawning. And so you got to be out there when it's snowing, when it's blowing, when it's miserable. But we had some really wonderful days in November too when it was nice out, and then the next day it would be miserable. But this is Fred right here, and once Fred turns on the radio transmitter, you can't go in because you got to find all the fish, which is great because we always did find all the fish. And this is the sonic receiver. This is a stationary receiver that checks the sonic tags. So this is radio telemetry. This checks the radio telemetry. So this is active searching. You're driving around on a boat with the receiver trying to find a fish. The fish would have to be probably within 250 to 500 feet of you, depending on how deep it is in the water column, with this particular tag to get a reading on it. So you start looking all over the lake, making transects, and then you get it and you zero in on the strongest signal. You punch it in, that's where that fish is. So this one is very, very accurate as far as finding this fish is under the boat right now. This system here with the sonic telemetry, each tag, the sonic tag that we put in, sends out a sonic signal, kind of like a nuclear submarine, that ping, 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 ping. And it's a sequence of 7 pings that's timed, so each tag has a separate sequence. And so when this thing picks that up, it knows, okay, that's tag 6403, and I'm picking it up here, so it's got to be somewhere in my vicinity. And we had 7 of these around the lake, and I'll show you where they were in a moment. And this is how we attach them. We attach them with a cable to shore, and in this little contraption here that the shop guys here at the school built, and it worked exceptionally well. We deployed them when we kept them out year-round. And we also had a handheld for active tracking of the sonic tags, or these are hydrophones. So you put that in the water and it'll listen for the tag, and it shows up on here when it gets a hit. This one is an omnidirectional receiver hydrophone, where if you put it in the water, it'll listen for 360 degrees around you. This one is a unidirectional receiver. So if you put it in the water, you'll know that it's within a cone of 40 degrees, whatever direction that's facing, and within 50 degrees up and down. So we had all the gear to figure this out. And this is where these sonic receivers were deployed on these different points. Now the names of these points, we made these up. We don't know that there was any historical names given to these points, but we had to have something to call them rather than call them point A, point B, or whatever. So Roe Point, this is where John Roe lives, and John was on the Lake District Board when we first started this. We call this Swizzle Point. Mark doesn't live there. He lives down in this bay, but he worked with us so much that we wanted to name a point after him. This one here is called Katie's Point because the Schenecker family lives right where the star is right there. And she's a wildlife biologist out in Colorado who we met that does telemetry work. So we thought, well, she's real close to this point. And this is we call Mason Point because this is where the Carter Mason property is over here. So, and that gave us some good points of references. And the boat landing is down on this end, of course. So that's where the receivers were. And by sticking the receivers around the edges of the points, if a fish is right out here, all these receivers are going to pick this fish up. They're all going to hear it. But by putting these around the points, we know that if a fish is over here, this receiver is not going to hear it. And the same thing if, oops, wrong one. There we go. There we go. So we can triangulate, we can create polygons of hearing where the receivers can hear the tags. And that way we can use some triangulation to figure out exactly or pretty close to what part of the lake that fish is in with the data that we download off those receivers. These receivers run 24 hours a day, 7 days a week, all year round when they're in the lake. And we download them once a year just pull them up, stick a Bluetooth key in them, it downloads right onto the computer. Millions and millions of hits because these tags, each tag is sending out a signal every 100 to 300 seconds. It's a randomized thing. And so we got lots and lots of data, in addition to all the handheld data that we collect when we're on the lake. So tons of information. We deployed them November 1st, 2017, and we pretty much track continuously, except for the time periods where we had to take the receivers out to do some maintenance or clean them or put new batteries in. And the really interesting thing about these tags, the sonic tags, they were built to give us the body core temperature of the fish as well as the depth of the fish. So each of those, the large sonic tags, the 10-year tags, when it would send a signal out, the first signal it would send out was, okay, and this tag is at 50 feet of water or whatever it is. And the next one would send a signal out, this tag is at 10 degrees centigrade or whatever the temperature was. So they're very, very high-tech tags and provided a tremendous amount of information. When we're out here tracking on the lake with both radio and the hydrophone, by active tracking, we'd be on the lake with the radio receiver, and Fred would be tuning in to where the fish are. All of a sudden, we got one, okay. Get right on it. We get on the fish, we mark the spot. If that tag also had a sonic tag inside it, or that fish had a sonic tag inside, we'd put the hydrophone down, it would tell us exactly what depth the fish was. Because with the radio tag, we knew the fish was right here, but we didn't know if it was 20 feet down or 70 feet down. But then we could get both bits of information and put them together. And again, we track day and night. During the summertime or non-spawning season in open water, about twice a month we'd be up there actively tracking. And then during the spawning season in October, November, we'd go up there for a week or longer at a time, and we track several times a day, and we track all the way halfway through the night. So are the lake trout surviving and eating smelt? So first, are they surviving? Yes, they are surviving when they are stocked off of Jeff Mason and Joan Carter's property right here. This property, within about one fishing cast, you're in 30 feet of water. So within one cast, you're out below the thermocline, which is the band of temperature change where you finally get the cold water. And these fish, anything stocked here, can very quickly get through the warm water and get out to the deep water. Previously, in 2005 and 2012, the lake trout were stocked at the boat landing here. Well, this bay is fairly shallow, relatively shallow compared to the rest of the lake. And lake trout are stocked in May. In May, this bay is full of predators. And the DNR even made comments that when they stocked the fish in 2012, they actually could see the lake trout being consumed by predators in the lake. When we started our sampling, we thought we had this stocking, plus this stocking in the lake to sample from. It turns out the only ones that had any survival were this stocking, which is the first one that occurred off of Mason Point. All the rest of these fish from 2005 and 2012, we think had very, very low survival, if any survival at all, because we only caught one fish from this 2012 stocking in all the sampling that we did. So that was a very important find, to know that the DNR did the right thing by switching its stocking from the boat landing to Mason Point, and that's also where we stocked the Cisco. So are they eating smelt? Yes. The stomachs were so packed with smelt that when we would make the incision to put the tags inside, you could see the smelt through the lining of the stomach wall. They were so packed. You could literally see the sides of the smelt right through that stomach wall. It was so distended from being packed with smelt. So yes, they're eating a lot of smelt, so we documented that. So are they attempting to spawn? And we used both radio and sonic telemetry to tell where they were trying to spawn. And especially the radio telemetry, the handheld, the active telemetry, because again, you could get right over them and you could figure out, yeah, that fish is here right now. And in 2018, we found concentrations of some of our tagged fish right off of what we call Swizzlow Point. The Steve DeMarco property is that white boathouse right there. That's where they were in 2018. There were fish there again in 2019, but the one really good female that we had, she moved from 2018 spawning over here, and we've evidence that she may have spawned on Katie's Point in 2019. So just an overview look at the lake of some of the different things we've talked about so far. These are the location of the receivers on the lake. This was Swizzlow Point spawning area, Katie's Point spawning area. Here's the stocking site off Jeff Mason's. Here's the boat landing stocking site, which doesn't work. But a couple of things to point out on this lake. With all the radio telemetry and sonic telemetry data that we collected, some patterns started to develop with these fish where we could go out there and we could find the fish pretty quickly, even in the summertime, that were tagged. When we first started looking for them, we'd start on this end of the lake. We'd do transects, 250 feet apart, back and forth, till we hit a fish. And we would enter that into the database. Well, after a while, you could start seeing a pattern. And these are the main areas where the lake trout seem to hang out the most, where we always, if we're looking for a fish, and some fish would end up in this area more, or this area or that, but we'd go right to those areas and invariably we'd find fish there. So we're this 1, 2, 3, 4 were major concentration areas for lake trout in the lake in the summertime. Just about any time, really, but especially in the open water season. So while I got this up, the green area here, that's what we call the littoral zone, 0 to 15 feet in depth, the place where vegetation grows. And this is, in any lake, the littoral zone is very important for the ecology of the lake, because this is where a lot of the primary production occurs of various types of aquatic insects, invertebrates, young fish, the spawning and nursery grounds of fish. And most lakes are going to have a littoral zone about this wide all the way around the lake. But because Long Lake is so deep and drops off so fast and the shorelines are so steep, it has very limited littoral zone, which means it also has very limited areas to produce forage fish, such as minnows and panfish and other things. So again, emphasizing the importance of having that deep water cold, or that cold deep water forage community, which the native fish was the Cisco, and that's the area that the smelt inhabit. So where, if and when are they spawning? If and when. So if they are spawning, when are they doing it? If you look in the literature for lake trout spawning behavior, it's fairly well documented that they have different, very interesting behavioral characteristics that they exhibit before, during, and after the spawning. And the first one is hovering or surface finning. They come to the top in the fall of they spawn in the fall of the year when the water temperature along the shoreline gets below 50 degrees. And that's at the time when they can come out of that deep cold refugia, because now there's shoreline water temperatures that are more comfortable for them. And lake trout will spawn anywhere from 6 feet of water to 60 feet of water. They have to spawn on rocks on good substrate that have interstitial spaces that the eggs can go down into and get stuck down in there that other things can't come along and eat them. And then they incubate there, and they'll spawn later in the winter, or hatch off later in the winter then. So they're spawning in October or November. So when the water temperatures inshore get dropped down to 50 degrees or 50 to 55, the lake trout can come to the surface then safely. It's cool enough for them. And they come up to the top and they surface fin. They come up and they spend time at the surface. And they find other lake trout. It's kind of like the lake trout singles bar, they're looking for each other. Then they travel around as they group up. Okay, oops, wrong one. There we go. Once they get into a group, then they quickly sink to the bottom where they spawn, where they're releasing eggs and sperm and releasing the gametes. And then after that's done, they quickly come back to the surface again. And then they start this whole thing all over again. They'll do this all night long. And it's mostly at night. There's been documented where there has been some during the day, but on Long Lake we saw the behavior primarily at night. So a key thing that triggers this is temperature. And what we have here in this chart, this is temperature in Fahrenheit over here. This yellow line would be the temperature in 3 feet of water. This line, the gray line, is the temperature in 65 feet of water. This blue line is the temperature of one of our tagged males, his body core temperature. And the pink line is one of our females that we had tagged. So you can see this temperature in low 40s is pretty constant for these lake trout through most of the summer. It'll go up and down a little bit because sometimes they'll go up in the water column to 25 feet or so to feed on smelt, then they'll go back down again. So it'll elevate a little bit. It might get up to 50 degrees, 55 degrees, or not low 50s, but it's usually pretty constant. But all of a sudden something happened here this is the time scale, September 27th to November 1st. So in early October, something happened. Well, what happened was the surface water got down to 55 degrees. The lake trout, okay, it's safe to go up to the surface now. They start coming up to the surface of the lake, which elevates their body temperature. We don't know exactly why that's happening, but it could be that they're using that warmer temperature, since they're cold-blooded animals, to hasten the maturation of their gametes or do something physiologically to them. And so we don't know that for sure. But it was right after that all of a sudden we saw this crazy activity where they're moving up and down in the water column, and they're doing this, what appears to be finning and hovering on the surface and then dropping down, coming back up to the surface in this time period here, right after this initial burst up to the surface. This is a plot showing one of the males we had tagged. Each one of these lines is 10 feet of depth. Here's the water surface, 10, 20, 30, 40, 50, 60 feet of depth. So right down here is 60 feet deep. And these are the depths of the fish. And this is a time scale from 9 o'clock in the evening till 2 o'clock in the morning on October 13th and 14th. And October, and that would be, this is in 2018. You can see this male over here, and this behavior was, this was way back for a couple days before this. If you look at it, it was all the same. He's down at 50 to 60 feet. He'll come up once in a while to feed on smelt, he'll go back down. All of a sudden, he goes to the surface at 10 o'clock at night on the night of October 13th. And he spends most of the time, or several hours there. Then all of a sudden he's up and down. And he's only down here for a minute or two, then he's back up again, up and down and up and down. Finally at 2 o'clock in the morning he says, enough is enough, I got to go take a rest. And he goes back into his mode that he was before. He did this for 12 days, this up and down behavior. So again, the coming up to the surface, the hovering or the finning, grouping up, finding a female, maybe a couple other males that go along for the ride, drops to the bottom, they do their spawning thing, come back up to the top. And this has never really been documented in this fashion before, and this is the first time on Long Lake that I've seen data like these. One of the things that was very disconcerting about this project was the death of our tagged lake trout. These are all the fish that we've tagged, and I don't expect you to memorize all these numbers, but there's 13 fish on here. You can see how we caught them, whether they had a radio tag or a sonic tag or both. We started tagging in August of 2017. By June of 2020, 11 of the 13 fish are dead. Now, Fred and I have done surgeries on probably hundreds, if not thousands of fish in our career, many different species. And we're very good at it. We follow all the right procedures. We anesthetize the fish. Everything is sterile and clean, and everything is according to the book. We were taught by veterinarians how to do this. We've done it a lot. And so we thought we can't be that bad of surgeons that we're killing all these fish. So there's something else going on. So we started looking at our data. And what we found, and started looking at what was happening on the lake. And we noticed when we were working on the lake, each year there were more and more people out there trolling for walleye. Because in 2015, the DNR allowed trolling to occur on lakes in Vilas County, which had never had trolling legal before. It took a couple years, but it gradually ramped up where people found out that these big walleyes are down at 50 and 60 feet because they're eating smelter too, and you can catch these walleyes by trolling for them all summer long. All summer and fall you can catch these walleyes. And so there was a lot of trolling. There was a growth of trolling on the lake, and we thought that, and we know that these trollers are catching lake trout because we caught them trolling. And we felt that this is where the problem lies. They're bringing these fish up from very deep depths. There's lots of atmospheric pressure down there. Fish have swim bladders. And when you have a fish from even 30 feet, 30, 40, 50, 60 feet, and you bring that fish quickly up to the surface, what happens is the pressure in that swim bladder doesn't have a chance to get out of the fish, the air in there, so it expands. It actually will push their stomach right out of their throat, and the fish is totally distended and can't go back down. It can't swim back down. Now, a method that fishery scientists use called fizzing, where you will poke a needle into the side of the fish at a strategic spot to release the gas, can be done successfully, but it's not something that anybody can do. As a matter of fact, I mean, it's been proposed that maybe that might be one of the methods to try to minimize the impact of trolling, troll-caught lake trout on Long Lake. But if you look around the U.S. and Canada, out of 59 different jurisdictions that were questioned about whether they allow the public to fizz fish being brought up from deep depths, the vast majority of them do not allow it. They don't allow it. Well, okay, you might ask, why is that? Well, there's some more information here. Fizzing. In this method, fishermen puncture the swim bladder of the fish with a hollow needle to release the excessive air. While fizzing does help the fish return to deeper water, it can seriously injure other organs during the puncture, eventually leading to death. Ideally, anglers, and this is another article on fizzing. Ideally, anglers should do everything possible to avoid fizzing. Dirty needles can cause infections, and if you've missed the swim bladder by a mere millimeter, you can rupture vital organs and kill the fish. If you do it, you have to do it properly. To fizz or not to fizz? The answer, the individual angler, if they do it, they have to keep their fingers crossed that they do it right. So the bottom line is that it's probably not the answer to saving lake trout in Long Lake, and that the only answer is you're going to have to either minimize or eliminate the trolling because it's going to happen out there. So this is just some of the documentation of the deaths of our telemetered fish, because as I mentioned, the tags we put in the fish tell us the depth of the fish and the body core temperature, so we have all the hard evidence. This is like a CSI thing. We have it's cold case. We got, this is good information. And I've got 3 examples here. This is a female that we tagged on August 20th, 2019. We tagged her, we caught her right there on the lake just off of Jeff Mason's property in a gill net. We had 1 receiver out at the time because the other ones we had in for maintenance, but this captured the whole story, being in that basin. On September 27th, so 5 weeks after she was tagged, at 6:45 in the morning, she was at the surface, and we typically find that most of these fish are brought to the surface. They come to the surface, we assume being brought by anglers, to the surface either early in the morning or in the evening, when a lot of the fishing activity is occurring. She was brought to the surface at 6:45. By 8:30 that same day, she was dead on the bottom in 67 feet of water in a location not far from where she was brought to the surface. And this tells her story here. This is, let's see, what do we got here? This is depth on this scale, so surface down to 70 feet, and temperature on this scale, 65 degrees to 30 degrees here. And you can see she's both depth-wise and temperature-wise, she's just fine, and she was fine like that for the entire month that she was out there before she died. But then all of a sudden she's brought to the surface, her body temperature goes up. As she gradually sinks back to the bottom, which takes several hours, her temperature is elevated while she was on the surface, and then her temperature begins to go down, and she gets to this spot and she hasn't moved since. We can keep going back to that spot and finding her. She's dead. She hasn't moved. This is a male that we tagged on October 24th, 2017. We caught him trolling. At that time, we had all the receivers out that fall in the array. And on July 30th, so this is 9 months later, he was in this bay, and his behavior, basically looking at his depth, he was feeding on smelt, because the smelt will stack up in this end of the lake when you get a southwest wind that pushes the water and the bugs and everything to this end. The smelt follow that, they go up there. He was up there feeding. His body core temperature was 51 degrees, which you would expect. By 3:44 that same day, he was in 1 feet of water with the body core temperature of 71 degrees. So he was brought to the surface, he ended up in a different spot, and he died, and he's been in that same spot ever since. You can see and this is a fish that, this particular fish always had body core temperatures in the 50s because he spent a lot of time in shallower water just below the thermocline feeding on fish. That was that individual fish's behavior. So he was a very active feeder. I've got a few relatives like that too. But very active feeder. He obviously was caught. He was brought to the surface and died, and that's where he stayed. And this is the last example. This is a male that was tagged on August 30th, 2017, caught out here by trolling. The receiver array was out that fall then to track him. On July 2nd, 2018, he was 23 feet down in this bay, probably feeding on smelt. By July 3rd, he was in 1 feet of water over here, so apparently he got caught and was let go, couldn't go back down, died in the warm water, ended up in this bay. The really interesting thing is on July 6th, the tag completely disappeared from the lake. It quit sending, so either the tag malfunctioned, but that's a possibility, but more than likely it got fished out, disappeared. Again, this is a fish very actively going up and down in the water column feeding. He had that same behavior for the previous 10 months that he was roaming around out there. Gets brought to the surface, all of a sudden he's dying, and here he disappears. Well, how did he disappear? These are pictures on Long Lake that summer of an eagle coming down and grabbing a fish. That's not a walleye. That's a lake trout. Now, whether it's that fish or not is hard to say, but that might have been another lake trout that somebody caught and threw back that was wallowing on the surface and died. But that's probably why you don't see dead lake trout out there, because there's a very active eagle population up there, and they are very, very good at finding dead fish on the surface of the lake and cleaning them up. So lake trout they're very important for keeping smelt in the lake, or keeping smelt in check in the lake. And if that's going to continue to be a long-term goal of the DNR in the Lake District, then the lake trout mortality from trolling needs to end. I mean, that's the bottom line, because we lost 11 out of 13 fish that died, and even if there was a couple of them that might have died from natural causes or whatever, the majority of them more than likely died from trolling. We have the hard evidence to show that. So it's a very limiting factor for maintaining the lake trout population in the lake. So finally, on the walleye, are they eating smelt and are they reproducing? This is a typical nice long lake walleye, and I took this picture off their Facebook page. A very happy young angler. He's probably right over here with that fish. We've been out there enough. But anyways, walleyes of all sizes are eating smelt, and they're growing fast. We caught walleyes in different types of gear that we use, from 7 inches to over 25 inches. Every size range of walleye that we handled, where we sacrificed them and took the otoliths, looked at the stomachs, checked the sex, had smelt in their stomachs. Again, as I mentioned earlier, we use a trawl, and this is a picture of it, to sample the smelt. And we were trawling in the lake in October of last year, 2019, and we caught a bunch of different walleyes, from 7 inches up to into the mid-20s, walleyes in this trawl. And we were trawling just right along here, and we caught those walleye. In that mess of walleye, we caught a lot of them that were an odd size. And I say odd size because if you remember, the DNR stocks Long Lake in odd years. So they would have stocked in 2017 and 2019. This is the fall of 2019. Fall of 2019 fish that were stocked should be at the most 6 or 7 inches long. Fall of 2017 fish should be 11 to 12 inches long. Not this in-between size, this 8 to 10 inch size fish. And we had a lot of those in the net. So we just randomly collected some, took them, so that we're going to check and see what these are. And we collected a few other sizes as well. And we took the otoliths out of them. And you should even be able to see this on the camera. There's a line here, and then the edge. Well, this is a year mark. So these are fish that were captured in the fall of 2019. This would have been the end of growth in 2018, and this is close to the end of growth in 2019. So that's what we call the 1+ fish, or 2 summers growth, meaning that fish hatched in 2018, a year that was not stocked. So that was pretty significant. If you look at all the fish that we sampled, the ones in green are all fish that came from years that weren't stocked. Almost half of the fish that we sampled were from years that weren't stocked. So and we had fish from 2 different year classes, 2016 and 2018. So in this very limited sample, it shows basically that the walleye have been reproducing in the lake. Now maybe they started doing that since the smelt maybe are depressed or whatever, but it's important to note that the walleye are reproducing in the lake at this time, even with smelt out there. So walleye is also an important smelt predator, and they appear to be reproducing despite the presence and abundance of smelt in the lake. So to summarize the key research findings, the native ciscos still are relatively common in the lake and appear to be able to pull off successful year classes with the smelt present and abundant. The smelt are still abundant. They're producing year classes almost every year with fish up to age 7 that we captured. But predation appears to be impacting their population because 67% of them are dying each year. And they're spawning at a very small size. And this dwarfing is possibly occurring with gravid adults, meaning they're mature adults less than 4 inches long. The lake trout will survive if stocked off the deep water site. They are eating smelt, and they're growing well, and they're maturing in 5 years, which is a year or 2 faster than other inland lake trout populations in northern Wisconsin. So they're growing very fast, and they're maturing earlier. They appear to be attempting to spawn off the 2 areas here, Swizzle Point and Katie's Point, in 10 to 56 feet of water. And the anglers trolling in deep water for walleye, the trolling is inflicting significant mortality on the stocked lake trout. And walleye are eating lots of smelt and appear to be reproducing in the lake also with the smelt present and abundant. So all this information is summarized in a report that Fred and I just wrote. It's in a draft form right now. It's a 50+ page report, has all kinds of pictures and charts and good information in it. And this is being sent out to the members of the Long Lake of Phelps Lake District. And we encourage the Lake District Board to send this out to everybody so that they can basically see what their tax dollars have paid for in the last 4 years as far as fisheries research and the findings. And they can read all about it in this report. And we encourage them to take a look at this. It's still a draft. And send their questions and comments to me at this email address by August 1st. So ronaldmbrooke@gmail.com by August 1st. And we're going to take whatever comments we get back from them, we'll infuse that into the final document and have that ready in final publication form by October 1st. So in that report, we do have 12 recommendations or options for future management of the fisheries in Long Lake, looking at all the information that we collected, and I'll just quickly go through them. The first one is keep stocking lake trout. Lake trout, as I mentioned, are critical. They're a key predator on the smelt, and the walleyes probably can't do it just by themselves. You got to have that cold water predator that the only place they can live is in the same place that the smelt live, so that's pretty much all they're going to eat, are smelt. And for that reason, as well as the gene pool preservation, as I mentioned earlier, this is a unique genetic strain, and the population in Black Oak Lake isn't doing all that well according to the DNR. They're having some trouble getting eggs in some years. They're not seeing a lot of young fish in that population. So it's important to have these fish in here as another source, potential future source for gametes, for eggs and sperm. Eliminate trolling on the lake to minimize or eliminate the high mortality of lake trout due to the bycatch in the walleye trolling fishery. A critical action. Continue stocking the extended growth fingerling every other year in odd years at a rate of 10 per acre. And even though it appears that the walleye are reproducing in Long Lake, until we see that this just wasn't a flash in the pan in a couple years, it's prudent to continue the stocking to see if that reproductive success is going to continue into the future. If the mortality due to the walleye trolling is not minimized or eliminated, in other words, if the trolling isn't stopped, then it would be prudent to stock other smelt predators such as brook trout or brown trout, which have been stocked in the lake before, with no negative impact on the lake whatsoever. Both those species will eat smelt, they will live in the cold water where the lake trout live, and they will not reproduce in Long Lake. So it's basically a put and take thing. You put them in there, and until you can get this lake trout mortality thing sorted out, put these other species in there to keep the numbers up of smelt predators. And then when you stop it in probably 5 years or more, they'll go away once they either die or caught out. To answer some of the walleye questions, it would be important to know whether they are reproducing in the lake. And there's ways that you can go back, you can collect these ear stones, these otoliths, and you can look at the ages of the fish from a random sample of the walleye that are in the lake, and you can tell what years had strong year classes, what years had weak year classes, what years had no year classes, just from looking at the ages on those otoliths, because they're very, very accurate. And the work that I did previously when I worked for the DNR, we actually validated that the otoliths tell the truth, tell the true age, because not all structures off a fish tell you the true age of the fish, but walleye otoliths do. So you can do that, and you could tell the relative success of the hatches probably over the last 20 years, however old walleyes get in Long Lake, and they probably get to be over 20 years old. Knowing whether the lake trout are in there, we found that out, that they're in there and they are surviving, they're growing well. But when we're not netting anymore, it would be good for the DNR or some other entity or whatever to continue to do some monitoring of lake trout to see if you can still catch them, especially if this mortality persists due to trolling. And we've identified the spots where that netting can occur, and so to institute some kind of a standardized lake trout assessment would probably be a good thing. Again, looking back at the walleye issue, another recommendation would be to assess each year what kind of hatches the walleye are having. And the DNR does that right now by, in the fall of the year, they shock the shoreline of the lake, the electrofish. And the walleye in most lakes will come to the shoreline to feed in the fall when the water temperature drops to about 55 to 60 degrees. The young fingerling walleye, the 6-7 inch walleyes, will come inshore to feed. And you can take an electrofishing boat at night and go along the shore and you can capture them. It's a standard method that the DNR has used since the late 1980s. But on smelt lakes, we don't know whether the walleye are behaving the way they do in other lakes because they're feeding primarily on smelt. Even the 7 inches are feeding on smelt, which are not on the shorelines. So there's a question as to whether that type of sampling is as effective on a smelt lake as it might be on a lake that doesn't have smelt. We don't know that. That's a scientific research question that would have to be answered. But the DNR does go out there and shock, and they do catch some fingerling walleye in the fall of the year. Those walleye, when the DNR stocks them out, They're all marked with a chemical called oxytetracycline, which is a cattle antibiotic. The young walleye fry, when they're a 1/4 inch long, they're immersed in a bag of water with this chemical in it, and it puts a mark on their ear stones, the otoliths in their head. So you can take the ear stones out of those young fingerling walleye in the fall of the year, put them under a black light, and they'll fluoresce. If you get one that fluoresces, the core of that otolith fluoresces, you know that's a stock fish. If it doesn't fluoresce, it's a native fish. So if you go out and take a sample of 40 fingerling walleyes and take the otoliths out, ship them to the lab in Stevens Point where they'll got the equipment to do this, or some other DNR labs have it as well, you can tell whether the fingerlings you got are native fish or whether they're stock fish, even in the years when their fish are stocked. Because you can stock fish in a year that might have a natural year class. You don't know unless you do this sampling. And then develop and conduct some sort of a standardized smelt assessment with the trawl. We tried all kinds of different gear to catch smelt. The only thing that worked for us was the trawl, and it works quite well, just to track the smelt through time. 3 more to go here. Also, the Cisco, as a very important component of the deep water fish community, should be surveyed from time to time. The DNR does this with a standard gear, but it's very limited sampling. And with the information that we collected with our sampling on the lake, we could advise on what kind of gear and where you could set nets to consistently catch Cisco in a quantitative fashion, so you can look at your catch rate of Cisco in a certain amount of gear year after year to know whether your population is stable or going up or going down. And then the spawning habitat that's in the lake, we did like chain drags and anchor drags and side scan sonar to see that there's some really nice rock on these points right here. But how much is there? Is there enough interstitial space? Could it be expanded? Could it be improved? So that type of assessment could occur, which might help the lake trout in their spawning success over time. And then finally, 2 more. The Cisco that were stocked in the lake, as I mentioned, were all fin clipped. And aging fish is a very, very important part of fishery science. It's the most important data you can collect on fish are their age, because from that you can tell how fast they're growing and how fast they're dying and if they're surviving or not, if the year classes are surviving. So collecting those bony structures, these otoliths, you can also collect scales and fin bones, but they may not be as accurate. From the stocked Cisco, because they're clipped, you have a known age fish. So you can look at that structure and you can say, okay, the otoliths from the Cisco is telling me it's 10 years old. I know it was stocked 10 years ago. It's accurate. Or the otolith is telling me it's 20 years old. It was stocked 10 years ago. The otolith is not accurate. So over time, you'd be able to tell whether that structure is a useful structure or not. And that hasn't been done for Cisco. And then finally, the DNR does do their standard vertical gill net surveys for Cisco and other species in the lake, and that should continue as well. So anyways, to wrap up here, this is me and this is Fred out on a really nice day on Long Lake. We've gained more knowledge about the fisheries in Long Lake in the last 3 years than was gained in the previous 30 years. Fred and I, we talk about this, and we feel that we went from kind of the darkness into the light on Long Lake as far as the fisheries is concerned, because we know a lot about the lake right now and things that are going to be very, very helpful moving forward for management of the lake and management of the smelt, which is really what the Lake District was keenly interested in the beginning. And even with the smelt in the lake, Long Lake has a dynamic and excellent native fishery. It's still a fantastic place to go fish. It's not easy to fish all the time, but there really isn't any lake that's easy to fish all the time. But the lake trout mortality from the deep water walleye trolling needs to cease so the lake trout can survive and keep the smelt in check. Because smelt are a driver in the system. You need the lake trout, you need the walleye to keep the smelt in check, to begin to balance things out in the lake moving forward from here. So that's it. So I appreciate your attention, and hopefully you can take a look at the report. And if you have any questions or comments, send them to me at the email address that you saw a moment ago. Thank you.